All right, today we're diving into a real cosmic mystery. A few years back, astronomers found something in the clouds of Venus, something that just shouldn't be there. It's a chemical signal so out of place, it kind of challenges everything we thought we knew about how planets work. So let's set the scene. You've heard of Venus, right? People call it Earth's twin because it's about the same size. But it's a nightmare world. We're talking about crushing atmospheric pressure, temperatures that can melt lead, and clouds literally made of sulfuric acid. So you have to ask, what could possibly exist there that would kick off one of the biggest scientific debates we've seen in years? Our story really kicks off in June of 2017. A team of astronomers pointed the James Clerk Maxwell telescope in Hawaii over at Venus. They were looking for a really specific, super rare molecule, and it was a total long shot. But then, they found it. A faint signal, like a whisper in the static, of something that had absolutely no business being there. And that whisper, well, it pointed to just one molecule, the central clue in this entire scientific detective story. The molecule they found was phosphine. It's pretty simple, just one phosphorus atom and 3 hydrogen atoms. But on a rocky planet like Earth, finding it is a huge deal. See, phosphine gets destroyed by oxygen really fast, so if you find it hanging around, something has to be constantly making it. And on our planet, that something is either us, industrial processes, or way more interestingly, it's microbes that live without oxygen. And this is exactly why finding phosphine on Venus is so wild. I mean, sure, on a gas giant like Jupiter, you can get phosphine. It's forged deep inside the planet by just insane amounts of heat and pressure. But Venus? Venus is a rocky world. Its atmosphere should shred phosphine almost instantly. So if it's there, something has to be pumping it out constantly. And they didn't just find a tiny whiff of it. The signal pointed to a concentration of about 20 parts per billion. Now that might sound small, but it's actually thousands of times more than what we have in Earth's atmosphere. To keep that level steady, something on Venus has to be producing this stuff at a pretty incredible rate. Now, you can't just drop a bombshell like this without some extraordinary evidence. The team knew that a single, faint signal just wasn't going to cut it. They had to be absolutely, positively sure. So here's what they first saw back in 2017. It's a spectrum, and that little dip in the middle is where the phosphine signal should be. But look at all that other noise, all those wiggles. Was that dip real, or was it just a random blip in the data? So the team got to work. They used all these advanced techniques to filter out the noise from the telescope. And after all that cleanup, boom, a much clearer signal popped out. That sharp, deep dip you see there, that is the unmistakable fingerprint of phosphine. But even with this cleaner signal, you still have to be skeptical. It could just be an error without one specific telescope, right? In science, the gold standard is independent confirmation. So they went and got time on an even more powerful instrument to double-check their work. And this is the moment of truth. In 2019, they used the amazing ALMA observatory in Chile, and they found it again. The exact same signal, at the exact same wavelength. But this time, it was so much clearer. The detection was real. This right here is the smoking gun. What you're seeing is the data from both telescopes laid on top of each other. You see all that random noise all over the place? But there's only one spot where both data sets dip down together in perfect agreement. That's the phosphine. The odds of this just being a coincidence are, well, they're astronomical. Okay, so the phosphine is real. The next step for the researchers was to try and explain it with normal chemistry and geology, to rule out every single natural cause they could think of. They basically made a checklist of all the known non-life sources. Could it be from volcanoes? What about lightning strikes in the atmosphere? Maybe meteorites were delivering it. Or could it be some weird chemistry happening on the surface or powered by sunlight? They modeled every one of these scenarios. And the results were just stunningly clear. They all failed. And not just by a little bit. The most generous models for things like volcanoes and lightning couldn't produce even a tiny fraction of the phosphine they saw. They were off by huge, huge margins. So there was one last thing to check. What if it was a case of mistaken identity? Could the signal actually be from another molecule that just looks like phosphine? The number one suspect was sulfur dioxide, which is super common on Venus. But the data just didn't fit. See that green line on the chart? That's what the signal would look like if it were sulfur dioxide. It's this broad, shallow curve, completely different from the sharp, deep dip they actually saw. So, nope, it was definitely not sulfur dioxide.
So, where does that leave us? The signal is real, it's definitely phosphine, and all the known natural explanations have been ruled out. Which brings us to the paper's very cautious but very profound conclusion.
After this incredibly thorough investigation, the research team was basically left with a giant mystery. Nothing in our current understanding of how planets work can explain why there's so much phosphine in Venus's atmosphere. And this is the most important takeaway. The scientists were so careful not to jump to conclusions. In their own words from the paper, they emphasize that this is not strong evidence for life. It's evidence for, and I quote, anomalous and unexplained chemistry. So we're left with this incredibly tantalizing question. High up in those Venusian clouds, the conditions are still extreme, but maybe not totally impossible for some kind of life to exist. Could there be some kind of aerial microbes producing this gas? Or is there some brand new, totally bizarre chemistry going on that we haven't even discovered yet? For now, the signal from Venus is loud and clear, but what it's trying to tell us? Well, that remains one of the most exciting mysteries in all of science.